Quantum technology could reshape the future of AI by supercharging its capabilities. In this video, we'll examine how Nvidia is positioning itself across competing quantum platforms and why it matters. Then we'll put a spotlight on PsiQuantum, a company that's betting big on photonic qubits and a radically different path to scale. I'm Geis, and this is AI Venture Watch. All right, so I'm going to bring out Nvidia into this scene, and I'm going to show some of its investments. Now, what comes back? Three companies: Q-Era Computing, Quantinuum, and PsiQuantum. Now, PsiQuantum is where we'll be focusing, but before we do, let's just take a look at the different quantum technologies that each of these companies is concentrating on. So I'll expand where they belong. And what comes back, you can see here PsiQuantum and photonic qubits. That's where we'll be spending most of our time. Quantinuum is in trapped ion qubits, and Q-Era is in neutral atom qubits. Now, we'll talk about these other technologies in another video, but right now we want to come back and concentrate on this area, specifically which deals with photonic qubits and PsiQuantum. First of all, a little background on PsiQuantum. Now, PsiQuantum is developing utility-scale, fault-tolerant quantum computers based on a photonic architecture, as we've seen. What utility scale means is simply useful. It's going to be useful for real-world applications. It's founded in 2015, and the company leverages semiconductor manufacturing. It's partnering with global foundries. This is important. It's facilitating quantum chips on silicon wafers, enabling scalable production. Okay, again, very important. PsiQuantum strategy centers on the belief that mature, high-volume semiconductor manufacturing offers the most direct path to the million-qubit quantum computer, which is widely regarded as the scale that's needed to be able to achieve real-world problem solution. So it's a manufacturing-first approach. It's a high-risk, high-strategy, high-reward strategy return that skips the development of smaller, noisy, intermediate-scale quantum systems in favor of a utility-scale, fault-tolerant computer from the start. So either build a system that solves real-world problems or fail. Now, to do so, obviously, it requires a significant amount of capital and R&D capability, and we'll see how PsiQuantum has accomplished this. So that's PsiQuantum. Now, let me give you a little background on photonic qubits. And to do so, I'm going to go to a PowerPoint deck. Okay, so here's the PowerPoint deck. Photonic qubits harness particles of light, photons, not surprisingly, to encode quantum information. Now, thanks to the principle of superposition, a single photonic qubit can exist in multiple states simultaneously, much like a coin spinning and flipping. It's both heads and tails until it lands, so it can be in either state. Now, this reminds me of a story. When I was taking quantum physics, the physics professor bet a student that he could flip 10 heads in a row. Now, the odds of doing that, you may know, are 1 in over 1,000. So the student took the bet. It turns out the physics professor was using the principle known as the conservation of angular momentum, which causes a coin to stubbornly resist any force to make it tumble. Even though it looks like it's flipping, it's kind of spinning more like a frisbee, really not flipping. So the coin soars through the air, spinning dramatically, but doesn't flip. It's a flip without a flip. It's a beautiful trick of physics. Our physics professor won the bet because he could flip 10 heads in a row. The point is that in this case, the qubit is actually occupying both states simultaneously. It's actually, quote unquote, flipping in that sense, or spinning in such a way that both positions are possible. So scientists typically encode information in a photon by adjusting its polarization, the orientation of an oscillating light wave. Now, Let's talk about the advantages of photonic qubits. They travel at the speed of light. They're remarkably resistant to decoherence, the loss of quantum coherence due to environmental interference. They can transmit quantum information across vast distances using fiber optic cables. And these traits make them ideal for quantum communication. The sensitivity to observation is a built-in security feature. Any attempt to intercept a photon alters its state, leaving behind a detectable trace, perfect for ultra-secure networks. We're going to see why the Air Force and other defense-oriented industries are interested in this type of technology. All right, here's the major obstacle. Ironically, the very feature that makes them excellent messengers, minimal interaction with their surroundings and their speed, is a major obstacle for quantum computing. Quantum logic gates rely on qubits interacting and influencing one another, but photons, by their very nature, tend to pass through each other without effect. Their lack of interaction makes them difficult to perform what is called entangling operations that's necessary for complex calculations. So overcoming this challenge, getting photons to talk to each other, is one of the central quests in photonic quantum computing. Researchers are exploring workarounds, including integrating photons with other quantum systems in hopes of unlocking their computational potential. Well, let's go back to the scene and explore PsiQuantum in more detail. All right, we're back to the scene, and I want to take PsiQuantum and show you some of its events. Okay, so I'll expand, and there's some events that come back. It's very intriguing. Let's take a look at these. For example, here it announces a chipset. On February of 2025, it had cracked a challenge on the road to commercial quantum computing. The company announces Omega, a quantum photonic chipset developed with its partner, Global Foundries. The chip processes information using photons and can be reliably built at scale using existing semiconductor fabs, solving a critical production bottleneck that has hindered quantum technologies. So that's the first event we want to consider. So then let's look at this partnership that emerges. A few months later, PsiQuantum announces a $10.8 million contract with the U.S. Air Force Research Laboratory. It continues a partnership to deliver novel quantum chip capabilities. The relationship is significant not only for its monetary value, but for its alignment with national priorities in quantum information science and the defense industry. We've seen this before when we saw the advantages of photonic qubits in communication technologies. Now, the Air Force is exploring also other quantum technologies, but photonic qubits and PsiQuantum is a major contender. Okay, let's look at the next important event, the Series E funding for PsiQuantum. To do so, let's take a look at Nvidia's investment in this round. And you'll see that Nvidia participated in the $1 billion Series E round that had a pre-money of $6 billion. So it's a significant amount of money that PsiQuantum is raised on September 10th, 2025. So Nvidia, through NVentures, its corporate venture capital arm, participated in PsiQuantum's raise of $1 billion in the Series E. Pre-money $6 billion, as we've said, is led by BlackRock and others. Nvidia will collaborate on quantum algorithms, GPU, QPU, that's quantum processing unit, integration, and photonic chip performance. So that's Nvidia's participation. Now there's one other event that we want to talk about. That is the Chicago area groundbreaking. Let's take a look at this. Recently, September 30th, 2025, PsiQuantum broke ground on its facility in Bolingbrook, Illinois, launching the construction of the first US-based million-qubit scale fault-tolerant quantum computer. The machine is designed to solve commercially valuable problems that are intractable even for the world's most powerful supercomputers. The facility anchors a new quantum innovation district, a project that promises thousands of jobs and billions in economic impact, trying to position Illinois as a global leader in the quantum future. All right, well, that's a wrap on photonic qubits and PsiQuantum. In upcoming videos, we'll dive into other quantum contenders, including other bets Nvidia is making across the field. And remember, if someone wants to bet you that they can flip 10 heads in a row, just smile, recall our discussion on angular momentum, and walk away before the coin leaves their hand.